Bangladesh is rapidly scaling its clean energy grids and IT networks, building a massive technological footprint designed to power millions of homes and businesses over the coming decades. This entire modern landscape depends on high-density power. Specifically, it relies on large-scale commercial energy storage systems to hold and distribute massive amounts of electricity. These multi-million-dollar installations form the physical backbone of the nation's future economy and telecom capabilities. If they fail, the network goes dark. Because we are packing so much energy into such tight spaces, we are introducing highly concentrated risks that traditional safety protocols simply were not designed to handle. Inside these densely packed lithium-ion cells, the real danger starts at the microscopic level. If internal temperatures rise, the chemical structure begins to break down, releasing explosive gases in a completely invisible reaction. This reaction can rapidly escalate into what engineers call thermal runaway. It is a self-sustaining, uncontrollable chemical fire that ignites from within the battery itself. Once that internal ignition happens, traditional reactive fire suppression systems are completely useless. Water and standard chemical foams cannot penetrate the cell casing to stop the chain reaction. For infrastructure operators, this means that waiting to see smoke or flames equates to accepting the total destruction of the entire facility. Protecting these investments requires stopping the fire before the very first spark is generated. To prevent catastrophic failures in these environments, operators have to engineer safety into the foundation by following the strictest international standards. The baseline for this level of security comes from the National Fire Protection Association. Securing modern energy storage requires strict compliance with NFPA codes 69, 72, 75, and 855. These specific codes mandate a total shift in how we approach safety. Instead of reacting to a fire, the engineering requirement is now focused entirely on detecting the specific off-gases produced right before a battery fails. Constructing Bangladesh's modern grid without meeting these international benchmarks leaves the entire network exposed to guaranteed failure. To meet these rigorous prevention codes, facilities are now relying on a uniquely integrated technological combination: ultrasense prevention and detection systems paired with StatX aerosol fire suppression. First, ultrasense sensors monitor the air for hydrogen and volatile organic compounds, the off-gases released as a battery breaks down. This data is routed through a central hub to identify anomalies within seconds, preventing thermal runaway. Additionally, dedicated smoke sensors provide comprehensive environmental monitoring. If off-gases reach critical levels, the suppression phase takes over. StatX aerosol is instantly deployed, neutralizing the hazard rapidly and safely without damaging adjacent electronics. The entire sequence happens automatically, requiring zero human intervention to stop the threat. By catching the failure in its chemical phase, this integrated system downgrades a total loss scenario into a manageable, routine maintenance alert. Upgrading to this level of technology also solves a major operational drain. Legacy gas sensors demand expensive, continuous upkeep, requiring mandatory routine calibrations and frequent bump tests just to stay active. Modern ultrasense sensors are engineered to be calibration-free. They eliminate those costly maintenance schedules and bypass the need to replace sensor cells every 3 to 5 years. This graph tracks the cumulative 10-year expenses for both legacy and modern systems. As you can see, by eliminating routine calibration and cell replacements, calibration-free sensors deliver an 82% lower total cost of ownership over a decade. Implementing international-grade protection reduces long-term operational costs, making it the most financially responsible way to secure high-value infrastructure. As Bangladesh continues to build out its clean energy and telecom networks, deploying this exact level of preventative engineering is essential to keeping the grid online. This internationally compliant next-generation technology is already available and actively being integrated into facilities across the country. The exclusive local engineering partner driving this deployment and providing this critical layer of protection to the nation is Optimum Engineers Limited. To ensure the technological future of Bangladesh remains safe and resilient, the next generation of infrastructure must be protected by the experts. Stay with Optimum Engineers Limited.